The floor is yours.
Um, Hello, everyone. Can everyone hear me?
Yes.
Okay, so good afternoon to everyone. So today's presentation is going to be on social network analysis and fake news detection. So basically, I'm going to start with the few papers that I have read throughout this week, and this presentation is going to be compiling of those paper. Presentation is going to introduce a basic concept of social network and analysis, and how can we relate those learnings from social network and those representation into the fake news detection. So that's going to be about the whole presentation is going to about those things. So let's start with few very basic concept of social network. In social network, there's always going to be news dissemination that is on the ecosystem. Basically, we'll be looking into the three dimensions of that news. The first one is content dimension, like what that news really contains, what it's all about. The second one will be the social dimension of that news, like who are the publisher of that news, how is it being spread, who are the users that are interacting with that news. And the third, another important dimension is the temporal dimension, like how fast is that news propagating, how fast it has been published, and how fast it is reaching to the mass users. So that's the third dimension that we're going to look at. Basic properties, not the actual properties, but properties in terms of, in a broad sense, there is the echo chambers that we need to think about. Because people basically, there is a community of people, like-minded people that that do not go beyond that community in practice and also in the social network as well. So homophily comes into that action. There are individual users who don't interact with much with the other users. There is filter bubbles, and filter bubbles are the result of a machine learning algorithm. For example, if someone is a fan of football or soccer, most of his news will be based on that particular sport rather than other sport in the social media. The third one is malicious accounts. The thing that we need to look into is there are not only users, but there are also bots that are active in propagation of the fake news. And if you talk about what are the types of network, right now we're trying to keep it simple. So it will be a homogeneous network, which will have the same nodes and same link types. The another could be the heterogeneous network, which will have the different nodes and different types. For example, we can develop a relation between the news and the author, instead of news and news, or instead of the author and author. So the figure that here we're showing is the three dimension of the social network. We're going to look into the social dimension. We can see that there are users, and there's a content dimension, like how that particular news is related to not only the news, but we also need to look into what are the comments in the news, what it contains itself, because it does determine like whether it is a fake news or not. For example, in a fake news, you'll see both the opposition party of the fake news and both the supporting party of the fake news interacting with that particular news. So that also does play an important role in order to determine whether it is a fake news or not. So basically, this is a homogeneous network. We can, there are different kind of homogeneous network. It could be friendship network, diffusion, or the credibility network. Why credibility? Because as I said, that it also plays an important role. If you look into the actual true news, there might be supporting, there might not even be supporting for that news, because people do not tend to go in and interact with the true news. They say, okay, this is the true news, and they move on. They just they don't engage that much. But if it's a fake news, then there is much more engagement with the supporting and opposing. So that we need to look into who are the users that are actually supporting that, and who are the users that are actually opposing that, because that can help us determine the community, and that can help us determine a particular friendship network. So that's why this is important as well. This is a heterogeneous network in which it could be a knowledge network, a stance network where users stand, and the interaction of the network. Another important thing that I want to discuss is the temporal diffusion representation, because why we need this is we need to one important aspect, and I'm going to focus on this representation more than the other representations, because one important aspect that we need to look into while determining fake news is how fast it is being propagating. So that information propagation, it can be for the user one, it can be represented at time t1, and then user two interacts with that at t2 and then t3. So we need to look how that information is propagating, and it will give us two things. The first one is social relation between the social relation from that propagation, as well as how fast it is being propagated. So we can compare this in into the two networks. The first one is true news network, how it is propagating, and we can look into the same temporal diffusion representation in the fake news network, and we can determine, okay, how these two are being propagated, and that will help us learn the feature of the fake news as well as the true news. And we're going to use that features in while training our model. Basically, we can see this. The most important here is this formula. So, and it's basically the number of nodes. Delta t is the time that the time difference between the engagement, and XUI is basically the user, X of SI is the content. Why we need content is we also need to know what kind of news it is, the news content itself. It also gives another important aspect that we need to look into is that not only the news, but we also need to look into the what news content itself. That is basically the perspective one of our whole research, that deception itself inside the rumor itself inside the fake news. So this formula is just basically telling us that we need to combine both the propagation as well as the deception in the news. I'm going to, since we have limited time, I'm going to move into how we can represent that temporal representation. We know that RNN are really good at modeling the sequential data, so we sure can use the RNN in order to model this temporal representation, because there is sequence here, and we can in basic language you can see that how we process text with the RNN. We can use the same methodology in order to represent the this sequential data as well. This is basically from the first paper, and the second most important compilation from the paper is user characteristics enhanced model for fake news detection in social media. So what this really does is, I'm going to explain in the figure. So this model, what it does is it looks into the both aspect of the user representation as well as the news representation, and it concatenates both of them. And again, it looks into the context of that news content, what it contains itself, is send that into the embedding layer and convolution layer, then concatenate itself and then pass it to the activation function. So what this network is also doing is basically, it is also looking into the content of that news being propagated. And the other thing that it is looking into is the user and the news representation, both that network that is being formed by the user as well as the news. So it is this paper also focus on two things, is that in order to determine fake news, we need to look into the propagation as well as the news content. So this paper also suggests and support our research that we need to look into deception as well as the propagation of the news. This paper, they with this UCM model, they did try with the two data sets, the BuzzFeed and the PolitiFact. And PolitiFact is the larger data set that we worked on before. They actually got a pretty good result of 0.932. It does not PolitiFact. It does not contain everything that's in the PolitiFact, but the data set they are using is the fake news net. So what it has is it has the URL of that particular news that has been published. It has its ID, and it has the Twitter users IDs, so that we can form the network based on that. And same goes for the BuzzFeed as well. So we can see that UCM, it performed really good with the PolitiFact fake news data set. So that's 93%. With the precision is 93%, even the F1 scores are pretty good. That is 92%. So that is a good score. The other paper that I'm going to discuss here is rumor detection on Twitter using the recursive neural network. Um, the recursive neural network and recurrent neural network is almost same. It's just that in recursive neural network, we can imagine this as a tree structure. In the recurrent neural network, you can imagine as a being unfold for each and every time sequence data. But here, what author really does is uh, he, he creates a tree based on the tweet, and that tree is being processed using the recursive neural network. The Here, for example, so I'm going to explain how the author did the modeling and how he worked on this one. Is basically, for example, let's say there is a tweet. It could be fake news or it could be true news. So if it is a false rumor in the tweet, then there's obviously going to be the support to that news, and there's obviously going to oppose to that news. What author is really showing here is this is the root node or the main source of that tweet, and if someone is questioning them, someone is denying them, and there could be support as well. The other thing is when there is a retweet or a recomment in that particular news source, then again that particular retweet, that particular comment can have supports, and that can have the comment on that. So basically, there's going to be there's going to be a formation of tree in those things. So this is what the author is trying to use as a representation. So these things here, the support from the retweet, support from the recomments, and the opposition from the recomments, he tried to map them into the recursive neural network. So here's an example of the recursive neural network that he used. So this is basically example of, for example, the cat plays piano, right? And it could be, we can imagine as this is the root node, and there could be root source, there could be subtweet about it, there could be subcomment about it. So user goes from the, the author used two approaches. He goes from the top down. For example, he first embed this source rumor, then followed by the comments and everything. And then he then used the bottom-up approach, in which he starts going from the bottom up all the way down to the the last comment on that news to the top comment. So he found out that in both of these two approaches, that the bottom-up approach worked pretty well because the top-down approach worked pretty well because he used the what he used is, after going from all the way top to the down with the with the content representation of the news, there is he embedded the pooling at the end of the max pooling at the end of the tree, and then he fed it into the activation function. So that using that max pooling actually gave the pretty good result. We can see the result of the recursive neural network over here. This is basically bottom-up approach RBNN, top-down approach RBNN. So we can see that in top-down approach, it is giving a good result rather than bottom-up approach. So, and the dataset they used is Twitter 15 and Twitter 164. We can get the dataset from this Dropbox link. The another important compilation is from the paper by Zhang et al. So this is basically fake detector. So what the author is really doing is, author actually come up with a really good idea of developing two things. The first one is he calls that SFLU. So this is basically what this does is it extracts the explicit features as well as the latent feature from that textual input. And the other thing that he developed is he then worked with the gated diffusive unit, and then he combined both of them into the architecture for the fake detector. So let me explain like what he's really doing. So basically, we in the live data set there in the live data set from probability fact, that's the data set that that the author has been using. So he created the networks based on the user and the news article, because there are many users in that data set that have said those, that have made those claims. And so he's making a network based on the users and the news articles and the subject, because those news articles there were many news articles that goes into the same subject. So the authors use this relationship in order to create a network, and then pass it to the uh, first they get the representation from the HFLU, and then they pass it to the gated diffusion unit. If you look into the gated diffusion unit more clearly, it is kind of similar to how the with all those gated, it gives us a kind of little sense of the LSTM. But the good thing is that by creating their um, own model in order to process this, the authors were able to get the 63% of the accuracy in the by class classification, but the model did not perform well in the multi-class classification. As we recall, the PolitiFact dataset, it has both the binary, they convert the live dataset into binary classification, either true into false, and the other was by default there was a multi-class classification. The model did not perform that well in the multi-class classification. The thing is here. Here the conclusion that I made is because even the PolitiFact dataset itself is not that big in nature. It only has somewhere around 12,000 dataset, and when you're trying to create a network out of it, there might not be there might not be many creators. I remember, I think the claims from the Obama were somewhere around in the 400 to 500, and claims from Trump were around the same number. So if you're trying to create the network, it might not be sufficient enough in order to map everything. So that might be the reason. And when you divide the whole PolitiFact dataset into multi-class, that will just give the range of, for example, the false only will be in the range of 2000, and mostly false will be in the range of 1200. So that not give the correct, that will not give the sufficient network that might need it for the multi-class classification. So that might be the one reason why it did not perform that well in the multi-class classification. So this is another paper, important paper that I compiled over here. So the other, another important paper is network-based fake news detection, and this is the pattern-driven approach. So this paper tells what we need to look into the network when we are actually trying to work with fake news detection using social network analysis. So they actually focus on the four patterns, basically the network pattern, the more spreader pattern, like how far it has been spreaded, farther pattern, how far it is, strong engagement, and how dense is the network. So author actually did a pretty much good work with the determining those terminologies and those features that we can use in our if you're trying to do the supervised learning. So the first one is more spreader pattern. Like, it is basically saying that the number of users involved in spreading each fake news, or it could be the true news as well. So it is trying to get that, and it will try to grab those users in both the fake news network as well as the true news network. And it also tried to grab the user susceptibility. For example, how much a user is vulnerable to a particular fake news, because that plays an important role. There could be a user who might not know either that is a fake news or not, but if he's suspicious about that, he might share it to his friends that, okay, look into this news, it might look suspicious. But when an algorithm is look into that, it might see that user as a user trying to spread that fake news, right? So we need to calculate the user susceptibility, and that we're going to do based on two things: the number of involvements. We're going to look into the previous pattern, like if the user has been participating in spreading fake news or not. And the other thing that we're going to look into is the frequency of involvement. Like how many times the user has spread the true news and how many times the user has spread the fake news. We're also going to look into that. In case of more spreader pattern, we also need to look into the user influence, like how many followers they have, how many followers they have, what is the most, if any of the user tweets has been propagated to a farther extent or not, how popular is the user's tweets, how popular is the user's post. We also need to look into that in order to consider the more spreader pattern. The other aspect is farther distance pattern. Basically, this we're trying to look into how far the fake news has been gone. It actually has been proved by Bosugi et al. That fake news spreads farther than the true news. This paper is actually pretty good here. It gives the basics of these fake news detection and so how that fake news propagated in the social network. So based on this one, the paper, the author tells that we need to calculate the geodesic distance and the effective distance as well in order to calculate the farthest distance. So the effective distance, this concept is basically, it is saying that it is saying that the words need to be measured based on the volume of the information that has been flew among the nodes. So based on that, they will calculate the effective distance. Geodesic distance is basically the diameter of each fake news network and true news network, which is basically equivalent to the shortest path between the two nodes. Based on these two, we can calculate the farthest distance pattern. So this also provides us the two features that we can use. If we go back, it already gave us the more spreader pattern, user susceptibility. We can count the number of involvements, frequency of involvements, and user influence as well. Similarly, the third important pattern that we need to look into is the stronger engagement pattern. The author, they reveal that fake news stories can engage users more compared to the true news. As I told before, fake news, it has both the opposition as well as the support, right? So for a social network algorithm, it will boost the fake news anyway. If people are opposing, if people are saying in the comment that, okay, this is a fake news, this should be taken down, even that will boost the fake news. So it will obviously have more engagement than the true news. So we need to grab that stronger engagement pattern, and we can do this by two ways. We can see the individual engagement as well as the group level engagement. We can calculate that. And in the paper, I didn't wrote the mathematical interpretation here, but based on the in the paper, they have given the formula in order to calculate both of them. The fourth most important pattern we need to know is a denser network pattern. That here fake news spreaders, it forms a more denser pattern, denser network compared to the truth spreader. Because as you can see that when there is a stronger engagement, there will be a denser network, right? And the author gives the three different levels in which we can calculate the density. Basically, that will be ego level, trade level, and the community level. The trade levels, we can just count it is basically the a triangle that has been formed. It could be of different types, so we can measure that one. Even for this one, the author has given the formula. And the other we need to look into is the community as well, like how many community has been formed within that network. So if we recall, why I'm focusing on this one is, if you recall, based on these four patterns, like more spreader pattern, farther distance pattern, stronger engagement pattern, and denser network pattern. So there are the features that we can extract. There are the features that these things we can calculate these things from the given data set, and we can use those data for our in order to use that data in the data set in order to train our model. So that's why we need to look into these four patterns, and the user gave the authors have already used this pattern in order to determine the accuracy in the port defect data set as well as the BuzzFeed data set. As you can see that while they are using all four patterns, they actually received the accuracy of 92%. So this gives us this gives an insight that if we look into the propagation pattern of fake news, and if we calculate all those features, all those variables, then if we use that in order to train a model, then it will give us the much more accurate result. So this sums up that propagation, the propagation for the fake news and the propagation for the true news both are different, and we need to make sure that we need to make sure that we capture the right parameters in order to determine whether the news in the social media is fake news or not. We also need to make sure that just the propagation is not enough. There might be some true news that might get viral and that might get propagated in the that might get propagated just like the fake news. So
Bibek, you have one more minute.
that's why I like to conclude the whole presentation. So that's why I want to I come to this conclusion that propagation is not only the propagation of the propagation of for news is not enough in order to determine whether it is fake news or not. We also need to look into the deception that the news content itself. As you can see that in the recursive neural network, the author used the content in the UCEM model. Also, the author used the news content. That's what we are doing in our research. Also, we also looked into the deception content in the news. That was our first paper, and right now we are looking into the second perspective, that is the propagation of the particle news in order to determine whether it is a fake news or not. And the third perspective will be to compare the fact from the news article to the knowledge base. Basically, this paper is based on our second perspective and based on the papers that I've read and the presentation today. I conclude that fake news can be determined by looking into the propagation in the social network. And by doing the proper social network analysis, we can differentiate between the true news and the fake news. This is the reference. Thank you.
Thank you so very much, Bibek. This was an excellent presentation. I learned quite a lot. Before we move forward, I need to ask a quick question so back to Bibek's presentation. I do have a number of questions, but I want to give the chance to other sailors to ask their questions first. Nancy?
Hey, Bibek, I wanted to know, how were they collecting their data and assuring that it follows this model? Like, how did they know they were randomly sampled such that they would follow these properties so they can create features to feed into the network?
Yep. So most of the paper, all those papers that I have presented today, I think out of 4 out of 5 is the fake news in the data set, because it already had there's another lie data set that is very popular. It was from PolitiFact. So fake news data set is basically the compilation of the PolitiFact data set. So what they do is in the PolitiFact data set, there are claims made by the politicians and other people. So what they did is, so in that PolitiFact data set, they see that any claims or any particular news is how that news is being propagated in the Twitter, right? So they go and grab that news article from the PolitiFact data set because it has already been determined whether by the fact checker whether it is true or false, right? And to what extent also, like it is mostly true or mostly false, to that extent also. So it has already been determined whether it is true or false. So in the fake news data set, they go and look into the Twitter and see, okay, how many people are interacting with that particular PolitiFact particular news. So, and that's why they grab all those network from the Twitter and then compile into the fake news net. So that is the most usable data set in terms of that I found by reading the papers, that they are using the fake news net of the PolitiFact as well as the BuzzFeed. So that's what they are using. I hope I answered your question.
Yeah, it was fine.
Okay, thank you.
Well, to follow up on Nancy's question, are these data sets representative of the real landscape of fake news?
I have a mixed feeling on that, because if we look if we had looked the same thing like 2 or 3 years ago, I might say yes, but the time has been changed. Time has been changed since now, because we are talking about the social network pattern and it's always changing, right? So if we want to use those data set, that might not result in the same result if we turn our model today, and if we're going to give the input from the today's claims or today's fake news. So we might need to collect the data set based on today's network and today's network pattern, because social network pattern is always changing and we cannot depend on the pattern that has been that happened like 2 or 3 years ago, because these data sets are old. They're not the latest ones. So we want to, that's the one thing that we need to keep in mind.
Very well. Any other questions? Okay, so let me ask a few. If you go all the way to the final slide. So the level of engagement, how is this measured?
Sorry, Professor, which one?
The level of engagement, how strong the engagement of the audience has been with a particular piece of news or rumor. How do the authors or different papers measure that?
So in this paper, that they are saying is that, what they are saying is that they are trying to look into this. If you're talking about a stronger engagement, they are looking into two aspects, like the group engagement, as well as the individual engagement. For a certain news, it could be equivalent to counting the total number of times that the news stories has been spread. So that goes for the group engagement.
And how do they get the total number of times a piece of news has been
they look into the tweet IDs. They compare, for example, so the group engagement is basically they look into the tweet ID, and they calculate it based on that.
Do they assume that they have total visibility into the Twitter network, so they can see everything that has been written about that piece of news on Twitter?
Not really, because they have this fixed data set and they're compiling from that. So that data set is static and also world. I don't think they will look into all that aspect in that. Like, I don't think they, I don't think they look into like how engaged those are in all those aspects, because we need to look into the proportion of times that the news stories has been spread by susceptible users, as well as the number or proportion of the times that the news stories has been spread by the normal users, right? In order to determine the group engagement, because there are two groups, susceptible users, and there could be the individual users and the other normal users. So they're trying to find out the group engagement based on that in this paper. So they're just saying like what's the engagement from the group, that means the susceptible users, and what's the engagement from what's the individual engagement in that news. And I think they evaluated that based on the average spreading frequencies of susceptible, normal, and all. So it is kind of different in this paper that I read. There's this other paper, I don't remember actually whose paper it was, and there was engagement is basically how many users are retweeting that. So
number of retweets of the same tweet.
Yep.
Well, that's something that can be easily measured. You can just look at the number of retweets for a particular tweet. But when you're talking about engagement, and we are claiming that we are looking at total number of engagement, that gets a little tricky, because it's often not possible to look at everything that's being said about a particular topic in the entire Twitterverse.
Yes, Professor, I agree with that.
Even if you're talking about news articles, you still can't measure the total amount of engagement with a partial view of the landscape of that debate. So this is stronger engagement metric is a little iffy to me. Also, this paper does not account for the type of engagement. It can be positive, it can be negative, but yes, they don't really take that into account.
No, they don't.
Also talk about something called network similarity. Can you redefine that for me?
Professor, the network similarity, they only kept at the result. It hasn't been explained. And I looked into the paper, it hasn't explained about the network similarity over here in the paper. So they just write it down at the result section only.
Okay. The paper that used an alternative architecture, an alternative recurrent or recursive architecture, when was that published?
The recursive news, let me see. I think that was from, just give me one moment, Professor. Recursive neural network.
That's 2014.
Yeah, I think that's 2014 recursive.
What type of data were they looking at?
In recursive neural network?
Yes.
I think it was the data set from the data set in the Dropbox.
What did that data set include? Did that include any network features?
Yes, it did contain. I think it was similar with the Twitter dataset. That was the Twitter dataset actually. I only downloaded it. I haven't got the chance to look into it more carefully. But basically, what it had is it had this. I do have the. Sorry, just give me 1 second, Professor. So it has the tweets and the comments after that. So, for example, there is a collection. There is a news at the top. Followed by the comments and again followed by the retweets and who retweeted what. I do have that here, Professor. Just give me 1 moment here.
Okay, if it includes the network structure, that answers my question. And the other paper that looked into the susceptibility of different users, what were the metrics of susceptibility again?
Professor, which paper?
There was a paper that was referring to how susceptible each user can be to fake news.
Oh yeah, that's the final paper. This one.
I'm not sure that it's this one. Can you actually go back in your slides? Go up.
This one, Professor.
Oh, it's the same paper?
Yes, it's the same paper. So it is basically looking into the number of involvements and the frequency of the involvements.
Number of involvements, frequency of involvements over the total number of topics, right?
Yes, Professor. Over the proportion of the fake news among, yeah. So it is basically the proportion of the fake news among all news that user has been participated in. And the other is the frequency of involvement. Like I said, even the user could be, the other thing is that user might not know that is a fake news or not. So okay. He might even, he's just by wrong, that might be the mistake from him that he shared the fake news. And
which of these two metrics corresponds with homophily?
I don't think in terms of user susceptibility, you want to in terms of a user susceptibility, you want to talk about homophily?
I'm just trying to make sense of that. Yeah.
Oh, so this one homophily plays action. I said this one because what happened? It is based on the fact that when a particular user is, and let's not talk about the susceptible user. Let's talk about the normal user, right? So if a normal user is trying to share the fake news, he might say it is in the profile, or he might say it with his friends, right? And basically, homophily plays into action is that if the user that is active in sharing the fake news, he might share it with the people that are alike to him. For example, if there is a good news from the Republican Party and a particular person is a Republican, he might share it with the Republican supporters.
That makes sense. And does this paper publish a data set that includes analysis of homophily?
No, Professor, I don't.
All right. Sam?
Yeah, I have to leave like in a couple seconds for another meeting, so.
Yeah, so do I. Thanks for the reminder. Bibek, this was an excellent presentation. I really enjoyed this. I hope everyone else has done so as well. I really wish we could fit Shreya's presentation today as well, because her work is very relevant to what you are working on. But unfortunately, we'll have to table that until next Friday. Bibek, thank you so very much. And thank you to everyone who attended this meeting today. I hope that next week is going to be as wonderful or even better than this week in terms of productivity. And have a great weekend, everyone.
Thanks, you
Thank
too.
you. Thank you, Professor. Bye, everyone.
Bye.
Thank you.